Assalamualaikum warahmatullahi and very good morning to everyone. So today we're going to learn about acid, base and salt. So this basically this topic is a continuation from the topic that we learned last week. Okay. So before we start, let's see what we're going to cover in this video. Okay, so we're going to recap on the strength of acid and alkali. And also we're going to study a little bit more on the reaction or the chemical property of acid and alkali. Okay, this involve a relation between acid and base, relation between acid and reactive metals, relation between acid and metal carbonates. We're also going to look at some of the reaction involving alkali as well. Okay. So let's recap what we have learned about the strength of acid and bases. Last week we learned about how to calculate the strength of acid and alkali by using the pH. So now we're going to look further into the definition of strong acid, weak acid, strong alkali and weak alkali. And also we're going to relate the strength of acid and alkali based on the degree of dissociation in water. So you may have come across this word before when we are defining the acid and alkali. So let's have a look at this stimulus about the similarities between the acids. Okay, if you can see from the picture, the students are discussing about the strength of acid as well as the basicity of the acid. Okay, in the previous lesson we learned about the monoprotic, diprotic, as well as a strong acid and weak acid. Now we're going to learn a little bit more in detail about strong acid and weak acid. So the strength of an acid basically depends on the degree of dissociation or ionization of the acid in water. So as I mentioned earlier, you may have come across the word ionization or dissociation before when we are defining acid and alkali. So what is a strong acid? Strong acid is actually an acid that ionizes completely in water to produce high concentration of hydrogen ion. So this is actually quite an important term. Okay, so basically what is strong acid? Strong acid is acid that ionizes completely in water. It must be in water to produce high concentration of hydrogen ion. So I think you may have come across this ionization equation before when we are talking or when we are discussing about definition of acid. So when an acid ionized in water, they produce hydrogen ion. Okay, here you can see the ionization equation for hydrochloric acid. So basically, when hydrochloric acid ionizes or dissociates in water, it produces hydrogen ion. And for the strong acid, the ionization is complete, where all molecules involved, as you can see in the diagram over here, if we have 4 hydrochloric acid or 4 hydrogen chloride molecule when they are added into water, so what you will get 4 hydrogen ion and 4 hydrochloride ion. This indicates that all hydrogen chloride molecule ionize or dissociate in water. Okay, and this will give a high concentration of hydrogen ion. So on the other hand, if strong acid is an acid that ionizes completely in water to produce high concentration of hydrogen ion, weak acid is actually is an acid that ionizes partially, in water to produce low concentration of hydrogen ion. Okay, and in this case, we have ethanoic acid. You have this symbol over here, the reversible arrow, to indicate that some of the acid is not completely ionized. Basically the ionization is actually reversible. Okay, so if you can see from the diagram over here, okay, not all hydrogen molecule, not all hydrogen ion is ionized, and then some ethanoic acid remain as molecule, not turning into ion. So if you have over here, this is basically hydrogen ion, and this one is ethanoic ion. So some example of acid. So we have here hydrochloric acid. So so you don't actually need to memorize about the conductivity, but maybe you need to have a general idea about the pH. As we mentioned earlier, most of the strong acid, the pH lies in between 0 to 2. Okay, so we have here we have some example of weak acid as well. So we have methanoic acid, ethanoic acid, and citric acid. So how about alkali? So we see the definition for strong acid and weak acid. Now we're going to see the definition for strong alkali and weak alkali. So strong alkali is actually alkali that ionize completely in water to produce high concentration of hydroxide ion. So don't get mixed up. The definition is very similar. So both strong acid and strong alkali ionize completely in water, but for strong acid, the ionization produce high concentration of hydrogen ion, while strong alkali, the ionization produce high concentration of hydroxide ion. Okay, similarly over here, when sodium hydroxide ionizes in water, so you get sodium ion and hydroxide ion. And as I mentioned earlier, so the definition is very similar to between weak acid and weak alkali. So if weak acid, the acid ionizes partially in water to produce low concentration of hydrogen ion. Weak alkali, on the other hand, is an alkali that ionizes partially in water to produce low concentration of hydroxide ion. Okay, so ammonia is an example of weak alkali. So we have some example over here. For strong alkali, we got sodium hydroxide and potassium hydroxide, while for weak alkali, we got ammonia solution. So you can actually study a little bit more in detail about the strength of acid and alkali by actually visiting this website. So you can actually see the simulation. So in this website, you can actually play around with the concentration of acid or the concentration of alkali. You see what happened with the indicator. You can use the pH meter. You can use the pH paper. When you dip into the solution, what's going to happen. So this is quite an interesting activity. So I want you to actually try this one, either by scanning the QR code if you have multiple devices with you at the moment, or maybe you can try later by typing this address into your browser. So it will open the website for you, and then you can actually try. However, if you are using the mobile phone, maybe the function is not complete, or you can some function might not work well with the mobile phone. But if you try with the laptop or the tablet, I believe you will have a better view for this website. I mean for this simulation. Okay, so you can try later. Alright, now let's move. Before we move into the chemical property of an acid, let's recap what we have learned so far. So we learned about the strength of acid. We know the definition of strong acid, weak acid, strong alkali, and weak alkali. Now, in this part, we're going to learn more in detail about the chemical properties of acid and alkali. So you have some background knowledge about this reaction when you are in Form 2, when you are learning about acid and alkali. Okay, so this part will be divided into two. The first part, we're going to see the chemical reaction involving acid, and then the second part, we're going to see the chemical reaction involving alkali. Okay, you can see over here, so we're going to see the relation between acid and base, acid and reactive metal, and acid and metal carbonate. So this is actually the three chemical properties that we're going to study on the acid. And the second part, we're going to see the chemical reaction involving alkali, where we're going to see the reaction between alkali and an acid, alkali and metal ion, and alkali and ammonium salt. Okay, this is another activity that you can actually try at home. So this is quite an interesting activity to see actually what is the product for the reaction between vinegar and baking soda. So you can try this at home. You can visit this link, or you can type this link to your browser to see the guide. So what you need is actually a balloon, empty bottle, vinegar, and baking soda. Okay, this is quite interesting that you can try at home, okay, with your siblings, and then from there you can learn the reaction involving acid and base. Okay, so I'm going to leave it to you to try this activity at home by your own. Okay, so now let's move into what we're going to see more in detail. So as I mentioned earlier, we're going to see three important chemical reactions involving acid. Acid and base, acid and reactive metal, and acid and metal carbonates. So here are some of the equation, the example of the reaction. So we have the first one, the reaction. So the reaction between acid and base will always produce salt and water. Here we have example with the reaction between nitric acid and copper 2 oxide. The product is going to be copper 2 nitrate and water. So I want you to at least memorize this general equation, so that it's going to be easier for you to actually identify the product form for the reaction. Okay, the second one is the reaction between acid and reactive metal to produce salt and hydrogen gas. So what we are talking about reactive metal over here, although sodium and potassium is reactive metal, we're not going to use that in our reaction with acid because it's quite dangerous. So common reactive metal that we normally use is zinc and magnesium for this reaction. And the last one, the reaction with metal carbonate. The reaction between acid and metal carbonate will produce salt, water, and carbon dioxide. Okay, so by understanding the general equation, or we call it, so it's going to help you to predict the product form when you are given any particular substances for the reaction. Okay, reaction between acid and base. Okay, so usually reaction acid and base only you will get two products, which is salt and water. Okay, so a base usually metal oxide or metal hydroxide. I think previously we already learned about base and what is the definition of base. Okay, so you can see some of the some example of the reaction over here, and I'm going to show you in a minute the video of the reaction as well. Although you might not be able to do it at home, I think with the technology and the availability of the videos online, it's going to help you. It's going to help you greatly in understanding this topic better. Right? From the general equation, we know that the reaction between acid and base produce salt and water. Okay, so this is actually an activity that can be carried out in the lab. Okay, so we can carry out the in this example we have copper 2 oxide and sulfuric acid. Copper 2 oxide is added in excess to make sure that all sulfuric acid has been reacted. And then the excess copper 2 oxide will be filtered out, and then we got in the filtrate we got copper 2 sulfate solution. And then after that we can actually evaporate the water from copper 2 sulfate solution. So we're going to heat the solution until the solution concentrated, and then we're going to allow the solution to cool so that the crystal salt crystal can form. So this is quite interesting activity. You can do it at home with the supervision of your parent. You can actually try basic reaction between acid and base at home. Okay, but I believe the only available base at home maybe is a the only reaction that you can do at home is between acid and metal carbonate. It's quite difficult for you to get base at home. Okay. So we're going to watch a video on the reaction between sulfuric acid and copper dioxide. So it's going to help you to understand better about the reaction and also about the product form. Okay, let's watch the video together.
Hi everyone. Today we're going to be making copper sulfate crystals from copper oxide. We start off with a beaker containing some dilute sulfuric acid, and this needs to be heated. The reaction is far too slow at room temperature. When it gets close to boiling, you can start adding copper oxide, a bit at a time. You'll see that the cloudy solution soon goes a clear blue. The bubbles you can see are simply from the boiling, there's no gas given off here. Be careful not to add too much at a time, it can froth over. Keep on adding small amounts of the copper oxide until the solution no longer goes blue, and some copper oxide remains undissolved. That way you can be sure that all the acid has been used up. Let your beaker cool enough to handle, and then filter the mixture. You will see that you have a clear blue solution of copper sulfate and black copper oxide remains in the filter paper. If you have the time, you can simply leave the solution at room temperature to allow the water to evaporate. We're going to speed things up by heating it though. Put the solution into an evaporating dish and heat at a gentle boil. You don't want to get it completely dry as some of the copper sulfate might decompose, but once you start to see some crystals forming, take it off the heat and allow it to cool. You can then put it in a warm place to dry properly.
Alright, so from the video you can see that the reaction between copper dioxide and sulfuric acid will produce a blue crystal, which is copper sulfate. The blue color in the solution is actually contributed by the presence of copper ion in the solution. Okay, so this is quite an interesting activity to study about the reaction of to study the reaction between acid and base, and also later you will use same reaction to study about the formation of salt. Okay, which is going to be the next chapter. All right, let's what we call it, test ourselves what we have already covered. Okay, so there are 4 questions that you need to answer. So you can pause the video for now and then try to answer the question. Try to answer all the questions, and then when you are done, you can play the video to get the answer. Okay, you can pause the video now. Alright, so I hope that you managed to get the answer for all the questions. Okay, so you can you can actually check your answer with the answer that will be provided for you in a minute. Alright, so here is the answer for the question. Please check. I'm afraid that I might be giving you the wrong answer. So if any of you find that the answer is wrong, just let me know so I can correct the answer for you. Alright, so this is the answer. It's a very straightforward question. Okay, hopefully you managed to get all the question correct. Okay, now let's move to the second reaction of the acid. So the reaction between acid and reactive metal. Okay, as I told you earlier, so we're not going to be using any reactive metal such as sodium or potassium. So we're going to use either zinc or magnesium metal for the reaction. Okay, again, we're going to use excess zinc powder in this reaction. And then when the reaction is completed, we're going to filter out the excess zinc to get the filtrate, which is zinc chloride in this reaction. Again, the next stage is the same, to actually heat the solution or heat the filtrate until saturated to get the salt produced. Okay, and then we're going to allow this concentrated solution to cool off. And then hopefully from there you can get a very nice crystal out of the solution. Okay, so the chemical equation is given in the orange box. You can see the reaction between acid, which is hydrochloric acid, and metal, which is zinc, will produce salt, in this case, which is zinc chloride and hydrogen gas. Okay, now let's watch together the reaction between acid and reactive metal, which is zinc. Okay, let's watch together.
Welcome back to chemistry. This is Jeremy Krug with another chemical reaction. This time I have a test tube set up here, and I'm going to add just a few milliliters of hydrochloric acid. Hydrochloric acid. This particular acid has a concentration of 6 moles per liter, so it's pretty concentrated. Then I'm going to take a little piece of zinc metal. I have the zinc metal in my hand here, as you can see. It's pretty shiny, just like most metals are, and it's silvery in color. And I'm going to drop the zinc into the acid. Now those are bubbles of hydrogen gas. I'm making quite a bit of hydrogen gas here. So I'm going to put this other test tube on top so I can collect as much of that hydrogen gas as possible. And since hydrogen is less dense than air, most of that hydrogen should stay in the test tube. If I touch this, I can feel that the test tube is getting very warm. In fact, it's quite hot. So this is an exothermic reaction. So I'm making quite a bit of hydrogen here. All those bubbles of hydrogen are being produced. Now, when I'm satisfied that I've made enough hydrogen gas, and I think I've made quite a bit, I will let this run a little bit longer. I think that's probably good enough. When I'm satisfied that I've made enough hydrogen gas, I'm going to lower this. And we'll come back to that later. I'm going to take that hydrogen I just collected, and let's see what happens when I take this little flame and set the hydrogen on fire. Did you hear the pop? Now, this test tube is quite warm as well right at that spot. So this is an exothermic reaction too. And if you look closely, I bring this closer, perhaps you can see it, but inside, it's a little hard to see on the camera, but right inside this test tube is a little bit of condensation, which tells us that hydrogen burned, which means that it reacted with oxygen to form a little bit of water. And so it's a little hard to tell here, but we made a little bit of water. I hope you enjoyed this chemistry demonstration. Visit my website at www.krugslist.org for more chemistry tutorials and demos, and subscribe if you like what you saw.
Okay, so we have seen an example of the reaction between acid and reactive metal. I believe from the video you can see very clearly about what we call it, the confirmation test for hydrogen that you learned before, which is by using the lighted wooden splinter. So the pop sound produced is quite clear here. So hopefully you can memorize the step, in terms of what material to use, and then what is the result of, from the test. Okay, so you can see from the video we are using lighted wooden splinter, and then from there we get pop sound is produced. So this is actually to confirm that the gas inside the test tube is actually the hydrogen gas. Okay. So again, I want you to actually pause the video and then try to answer the question. Okay, and this time I'm not be giving out the answers for you. So you can actually answer all the question, and then if you have any problems, okay, you can actually come back to me. If you want a short discussion, you can also contact me to get the answer. Okay, you can start to do the exercise or the discussion now. Okay, I hope you get all the chance to answer all the questions. So now let's move into our last reaction in acid, which is the reaction between acid and metal carbonate. So this is also a good example of the reaction, and also you can see what happened when the acid react with metal carbonates. And if you can see from the general equation previously, the reaction between acid and metal carbonate will produce carbon dioxide. So how do we know carbon dioxide is produced in this reaction? So you can see from the picture over here. So if you can collect the gas, or if you can channel gas into the lime water, so what will happen? You will see the lime water turns cloudy. However, you might not be able to see same setup in the video that I'm going to show you, but you're going to see the observation when we add when we are adding metal carbonate into an acid. Okay, so let's watch the video. Okay, and then let's have some discussion when the video has ended. Okay, let's watch the video together. So alright, so you can see a lot of what we call it like bubble coming out from the mixture. So that's actually indicating that the carbon dioxide being released. And then you will find that sometimes calcium carbonate is also known as marble chips. Okay, or sometimes it's called a limestone. Okay, so don't get confused. Okay, the chemical composition of marble chips and limestone are the same, which is calcium carbonate, which is what we are using over here. Okay, but however, from the video, you cannot see the effect of carbon dioxide produced into the effect of carbon dioxide produced to the lime water. But I believe you can find a lot of video showing the effect of carbon dioxide to the lime water. So you see what does it mean lime water turns cloudy from the video. Okay. Right, so that's quite a short what we call it demonstration. So you can answer the question to see what you get from the video, and then from the sub part of the reaction as well. Okay, again, writing a chemical equation is quite essential for this part. So that's why you can see in the discussion part we ask you to write a chemical equation. You can also challenge yourself by varying the type of acid used. In this case, we are using nitric acid. You can also write down the chemical equation when the nitric acid react with calcium carbonate, sulfuric acid react with calcium carbonate, or even hydrochloric acid react with calcium carbonate. Okay, just to challenge yourself a little bit more, right? Okay, you can answer the question now. Alright, so I hope you managed to answer all the question. So if you have difficulties in answering the question, you may actually rewind the video and see the explanation in the video, or you may also have a look into your textbook to get the answer. Okay, because I'm not showing everything over here. I hope that you have the textbook with you so that you can get the answer from the textbook. Alright, to summarize what we have learned so far, so we see the reaction between acid and base will produce salt and water, reaction between acid and reactive metal to produce salt and hydrogen gas. Remember, not all metal react with acid. The metal does not react with acid, which is, I believe, you learned in Form 3 previously. Okay, you learn about the reactivity series of metal, so you know that some metal do not react with acid at all. Okay, so be careful. That's why we are saying over here reactive metal. We are not saying metal because some metal do not react with acid. And then the last one, acid react with metal carbonates to produce salt water and carbon dioxide. Okay, and the last part, or the second part of the topic, so we're going to see the chemical properties of alkalis. There are three reactions that we're going to have a look. The first one is the reaction between alkali and an acid. The second one, the reaction between alkali and metal ion. The third one, we're going to see the reaction between alkali and ammonium salt. However, I'm not going to provide you with any videos for this part. So we're going to go through the general equation and example of the reaction for each of these chemical properties. Again, so please remember this general equation for each the three reactions involving alkali. Okay, I hope you still remember what alkali means. Okay, and then so the reaction between alkali and an acid will produce salt and water. Okay, the reaction between alkali and ammonium salt produce salt, water, and ammonia gas. And the last one, the reaction between alkali and metal ion, you will get insoluble metal hydroxide and cation from an alkali. So we're going to discuss a little bit more in detail about the last part of this reaction when we learn or when we are covering topic salt later. Okay, so we'll be discussing a little bit more in detail about this. Okay, so I think we come to an end of our lesson for today. So just for your exit ticket, or we call it, just to tell yourself before before we end this lesson, I want you to write down in a piece of paper the definition of strong acid, strong alkali, weak alkali, and weak acid. Okay, make sure you can actually write it down and memorize by heart about this definition, and then write the chemical reaction for the following reaction. Okay, so I have listed down. So please write a chemical reaction. So this is also a good practice. This is also a good practice for you to practice the chemical formula and also the chemical equation, as well as balancing the chemical equation. Okay, because when you write down a chemical equation, it should be balanced. Okay, so you can copy down the question and answer them later, or you can answer all the questions straight away. So it's going to be easier for you, right? So before I end, let's recap what we have already learned today. The first part, we learned about strength of acid and strength of alkali, where you come across the term strong acid, strong alkali, weak acid, and weak alkali. And the second part, we learned about the chemical properties of acid and alkali. In the chemical properties of acid, we learned about the reaction between acid and base. We learned about the reaction between acid and metal carbonates. And also we learned the reaction between acid and reactive metal. Okay, and for the second part of the chemical properties, we learned about chemical properties of alkali. So the reaction between alkali and an acid, the reaction between alkali and ammonium salt, and also the reaction between alkali and metal ion, where you get the insoluble salt. So I'm not going to actually elaborate more in details about the reaction involving alkali and metal ion, because we're going to cover that one later. So at this stage, it is good enough if you understand about the general equation or general formula for the reaction. So it's going to help you quite a lot when we cover the topic later. Okay, so thank you very much for your attention and for your time to learn this topic. I hope that this video is going to be useful for you and helpful in understanding this topic. Okay, so thank you very much. Okay, see you again later. Thank you.